Hi everyone, I am Noazrizal Aswad, and in this video we will discuss about intermediate value theorems. So from the name itself, we already know what the theorem is all about. So we have here the term is intermediate value. So let's say we have two values, 2 and 4. When we talk about intermediate values between 2 and 4, we will talk about, let's say, 3, 3.2, 3.3 and so on. So intuitively, let's say we have a function here. So it is given by this simple graph, and we have points here A and B. So this A will give us FA, and this B will give us FB. So in intermediate value theorem, we choose a point between FA and FB. Let's say FC, and then we deduce that if FC is between FA and FB, then there exists a value C which is between B and A as well. So we have this implying this. So let's take a look at the proper way of writing the theorem. So it says here, if f is a continuous function on a closed interval, so we have condition here, a closed interval a, b, and if y naught is any value between fa and fb, then y naught equal to fc for some c in b. So we have several conditions here. First, must be continuous, where continuous on a closed interval. And then we have second condition, y naught is any value between fa and fb. Then we have y naught equal to fc for some c in ab. So we have here only if then, which means this theorem is one direction only, not two direction. Okay, so condition 1 here and condition 2 here, first if, second if, will imply the one after then. So let's take a look at the graph again. So let's say we have A and B in our domain, and then we have FA and FB. Similarly, intuitively, if we choose y naught between FA and FB, this guarantees that there will exist a value C here between A and B, given that FC equal to y naught. You choose something between here, you'll get something between here. It's very simple. So when intermediate value theorems or simply IVT fails, so we check again at the conditions for IVT to works. The first condition, the most important conditions, is that the functions must be continuous. So we have a sample function here, which is discontinuous, because intuitively you can draw this graph, but at here you have to leave your hand and put it back here before you continue drawing the graph. Let's say we choose a value between 2 and 3 for our y naught. Assume here 2.5. From the IVT, we know that if you choose the value between 2 and 3, which is corresponding to several values in x, so from IVT, it guarantees that the values will be between 2. Okay, we have, let me write here. Y naught equal to 2.5, FA equal to 2, FB equal to 3. So if you choose y naught equal to 2.5, we can never find any value C between B and A that give FC equal to 2.5. You see? If you can recall from our previous earlier classes, we know that the range 2.5 is not in the range. So IVT is that simple. Okay, there are things that you have to fulfill continuous on a closed interval, and then we have to choose a value between FA and FB, and then we need to find C between A and B. But in this case, in this slide, you see that the function fails because it is discontinuous. So let's take a look at one example. What is the use of intermediate value theorem? So the question here asks, show that there is a root of the equation x cubed minus x1 minus x minus 1 equal to 0 between 1 and 2. Okay, so our 1 here is our A, this is our B, and x cubed minus x minus 1 is our fx. So first we check FA equal to F1, which is equal to negative 1 less than 0. And then we check for FB or F2, which is equal to 5 greater than 0. So from our IVT, we know that there must be a value between negative 1 and 5 that we can choose. So in this case, we want to find the root. So we have to choose where f equal to 0. So we know that 0 is between negative 1 and 5. So IVT confirms that there exists x equal to c that will give FC equal to 0. So you can try to plot the graph for x cubed minus x minus 1. The graph is look something like this one. So let's say we have here negative 1. So this is our 1. Okay. And then we have 5 here. So this is 2. So we know that the root cross the x-axis, which is this line here. So you can choose y equal to 0 here. This is our root that we want to find. So from the fact that y equal to 0, we know that there is a value here that say we don't know that particular point C. So we have FC equal to 0. So we confirm that there is a root of the equation x cubed minus x minus 1 equal to 0 between 1 and 2, which is C. That's it. Thank you.